Shop the Plato's Closet Black Friday event in North Charleston and West Ashley and let the deals begin. You know Plato's Closet always has a huge selection of trendy recycled styles at amazing prices, but Black Friday deals are different. They're better. We've been holding back some of our best inventory, and you won't want to miss our Black Friday event. Save on gently used styles from Patagonia, Lululemon, Lilly Pulitzer, and hundreds of popular brands. Plato's Closet is ready to let the Black Friday deals begin. Plato's Closet, located in West Ashley on Sam Rittenberg Boulevard and North Charleston on Rivers Avenue.
Hello, once again, thanks for joining us. This is Space Nuts with Andrew Dunkley, your host, talking astronomy and space science. And coming up on today's show, we're going to talk about the first stars, the aftermath of the Big Bang and the first stars to develop because they may have been identified. And glass samples on the moon, what's that all about? The Chinese have discovered these with their Chang'e 5 mission. We'll also be answering a couple of audience questions as we do every week, one on antimatter and the other on fishing in a black hole. Now, last week I think we talked about cooking as a part of the show. We're really branching out on Space Nuts. So this week it's fishing, and but there's obviously a lot more to it than what I'm telling you. We'll get to that a little later, all coming up on this edition of Space Nut.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And joining me as he does week in, week out, month in, month out, year in, year out, and we're pushing on towards a century, is Professor Fred Watson, astronomer at large. Hello, Fred.
Hello, Andrew. Good to be here for the next century or so.
Who knows? Yes.
Yeah.
Episode 327 we're up to, so we're really racking them up.
Yep.
Going gangbusters. Yeah. I've got a story to tell you. This will be, I'll try to keep this quick, but my computer died. It was brand spanking new, and I came in to do some work and pushed the on button, nothing, dead, gone. So I contacted the company and say, what gives? And they said, well, we've got a 30-day replacement warranty. And we checked the receipt, 29 days. 29 days. So I got it replaced, so that's great. But boy, what a nightmare, because, I mean, okay, it's a brand new computer, but I have to start all over again. But the funny part is when I went into the shop where I bought it, I got to talking to the young fella there, Harry, and he said, what do you use your device for? I said, well, mainly to record a podcast. He said, oh, what's a podcast? I said, Space Nuts. And his eyes lit up. He went, oh, I listened to that. And you're, I said, I'm Andrew. Oh, that went well. But then when I got it home, I realised it didn't have a USB-C port, which the old one did, the old new one. So I had to go and buy a cable from another shop, and went in. They said, what do you need this for? I said, I need to plug my Rodecaster into my computer for the podcast. Oh, what's the podcast? This is where you're going to laugh. I said, oh, Space Nuts. And they all stopped. There's about 3 people behind the counter, and they all looked at me and went, oh, you're Andrew. We listened to that. And then the guy next to me, who was a customer, put his hand out and said, always wanted to meet you, and shook my hand. Couldn't believe it.
There you go. It gives a really good clue to the distribution of our audience and the cross-section of what they do. They all work in computer shops.
So I'm going to break my computer every week.
Yeah. Aware of it.
And I must give them a shout out for fabulous service. Everybody was great in getting this thing sorted out before they knew who I was.
That's nice.
So
that's good.
It was terrific. We better get down to business, Fred. Now, let's talk about the first stars in the universe. This is really fascinating in that you wouldn't think you'd be able to find much evidence of stars that came into existence, over 13 billion years ago, and yet even today we can still find telltale signs. I'm just assuming for a moment that they probably still don't exist, but then again, maybe a couple of them do.
No, you're probably right. They probably don't. The very first stars, which astronomers give a slightly gobbledygook name to, they call them population 3 stars. And just to explain a little bit about why that is, population 1 is stars like the Sun, which sit in the disk of our galaxy, which are very rich in in what we call metals. That's any elements heavier than hydrogen and helium. And so, you've got plenty of raw materials for planets and living organisms that are present in the atmospheres of these stars. Now, that's population 1. Population 2, however, are much more depleted in those heavier elements, and we find them in places like the halo of our galaxy and the nucleus, the center of our galaxy. So they're thought to be very old stars. But I guess it's a few decades ago now, it's probably 20, 30 years ago, people speculated that there must be an independent population of stars which were the very first stars to appear, population 3.
I think we actually did a segment on them some time ago, and we were talking about them probably existing.
Yes, that's right. And
it hasn't been proven yet or something.
On reflection, you're absolutely right, Andrew, because I have a colleague in the United States, Tim Beers, whose quest is looking for these things. And what you're looking for is stars that have got basically no metals in their atmospheres, because the gas cloud from which they formed was pristine. It hadn't been contaminated by all the other stuff that litters the universe. So that quest for population 3 is ongoing. But what we have here is a story which is a bit more circumstantial, but it is still good evidence for the existence of population 3 stars. And that is and I should mention these observations were made with the Gemini North Telescope in Hawaii, which has been looking at quasars. So quasars are basically delinquent galaxies. They're young galaxies with essentially a black hole gobbling up stuff at their center, and in doing that, the black hole becomes very bright, or the accretion disk around it becomes very bright, and so the quasar itself shines brilliantly from the other side of the universe. But some of these quasars are essentially immersed in clouds of gas and dust, and in particular, one of them has been examined, and the gas cloud around it has been investigated by spectroscopic means, breaking up the light so you get the barcode imprints of the various elements. And what they found is a very unusual ratio of iron to magnesium, with they said 10 times more iron than magnesium when you compare it with the ratio of those elements in the sun. In other words, this is a big difference between the chemistry of the sun and the chemistry of this gas cloud around the quasar. And the scientists who have worked on this, and in fact, I think at least one of them is from the first author is from the University of Tokyo, Yuzuru Yoshi. And what Yuzuru has done is looked at this mismatch between iron and magnesium and asked, well, where did this gas come from? How did it get like that? But they have also looked at what you expect to find if a population 3 star with between 150 and 250 times the mass of the sun and just made of hydrogen and helium, if that thing explodes in what's called a pair instability supernova. It's a particular type of supernova. So you get the explosion, and the debris that's scattered out into space it contains the stuff that's been generated inside this star itself. Even though the star started off with only hydrogen and helium, the nuclear processes actually generate the heavier elements. And it turns out that you get exactly this answer. The ratio that they found in this gas cloud is exactly what you would expect from a pair instability supernova of a population 3 star. So what they're claiming to have detected is not the star itself, but the debris left behind when that star exploded at the end of its short life. It's probably only a few million years.
That is short for a star, isn't it? When you
Yes,
consider
that's right. Our sun is about 5 billion years old. 4.6
and
billion years old.
there's life in the old dog yet.
There is, yes. There's another probably 3-4 billion years. And I've just found that one of the co-authors of this study, Andrew, is the colleague of mine that I mentioned earlier, Timothy Beers.
Oh,
Tim Beers, University of Notre Dame in the US.
fantastic.
So there you go. He's one of the authors. And that doesn't surprise me. He's always on the lookout for population 3 stars.
Mm. So they haven't proven that they've existed, but they are getting mighty close. Is that what we're saying?
I think this is pretty good evidence that they existed, because the only way you can get this odd ratio of magnesium to iron is by this pair instability supernova with this very high mass star, maybe even 300 times the mass of the sun, which would be a population 3 star. So yes, you're right. We haven't seen one yet, but this is really good circumstantial evidence. It's this.
Are there likely to be any?
Well, that's the question. And, if you got one that could somehow manage to last for 13.8 billion years till the present time, maybe there will be some. Maybe there will be low mass population 3 stars lurking even in our own galaxy. Actually, that's the comment that Tim Beers made. He said, we now know what to look for. We have a pathway. If this happened, and by that I mean this exploding star, if this happened locally in the very early universe, which it should have done, then we would expect to find evidence for it locally. In other words, in our own galaxy. Yeah. So, yeah.
Well, I'm sure Tim will be hard at work trying to
find.
You will,
yeah.
Sounds like he's on an epic journey.
It is, yeah. It's a truly epic journey. He's a great guy, actually. I haven't seen him for a long time, but yeah, it's an epic quest for population 3.
Tim's on a journey of one kind, and Yuzuru Yoshi is on a journey of another, because he's great mates with the Super Mario Brothers, as far as I'm aware.
Okay.
Some people will get that joke.
Yes.
Many.
Yeah, they're probably the blokes that fix your computer there that will get it.
Yeah, they were Super Mario Brothers for sure. Yeah. All right.
Good.
So circumstantial evidence, we'll call it.
I think that's the best way. In fact, really, it's the smoking gun. That's the best way to put it. Yeah. Even though it's not smoking, it's just shining.
Fair enough. All right. There might be more to tell about this story down the track, and who knows, we might be able to get Tim on Space Nuts to talk
that
about
would be
it.
great. Yeah, that would be great.
That'd be nice.
Yeah.
All right. This is Space Nuts with Andrew Dunkley and Professor Fred Watson.
Roger, you're loud and clear here also.
Space Nuts.
Now, Fred, let's turn our attention to the moon, which is the focus of a lot of attention at the moment, with China and the United States wanting to get more involved in being on that particular satellite. And, of course, we know about Artemis 1, which has had its launch date pushed back to November, is the latest news.
Yeah,
so they're not going to try and take advantage of the October window. They're going to give that the flick and make sure all systems are nominal for a November launch. So we'll have to wait and see on that. But the interesting thing about the moon is we keep discovering fascinating things about it. Now, beads of glass. What have they found, and what is it telling us?
Well, yes. So the beads of glass are not, they're not uncommon on the moon. They're known already. They were found in the lunar samples from Apollo, the various Apollo missions back in the 60s and 70s. But what we have now is a new sample of lunar soil brought back by the Chang'e 5 mission, a Chinese spacecraft that landed and returned samples of lunar soil. I think, if I remember rightly, it was in 2020 when that took place. So these have now been in earthly laboratories long enough to be fully analysed, and some interesting results have come out. And as I always tend to do, I'm going to quote some of the scientists themselves who are involved with this. This is from Professor Alexander Nemkin, I think is the way his name will be pronounced, from the School of Earth and Planetary Sciences. at Curtin University here in Australia. And Alexander says we combined a wide range of microscopic analytical techniques, numerical modeling, and geological surveys to determine how these microscopic glass beads from the moon were formed and when. And this is the interesting bit, Andrew. We found that some of the age groups of the lunar glass beads coincide precisely with the ages of some of the largest terrestrial impact crater events, including the Chicxulub impact crater, responsible for the dinosaur extinction event. The study also found, and this is still quoting Alexander Nemkin, the study also found that large impact events on Earth, such as the Chicxulub crater 66 million years ago, could have been accompanied by a number of smaller impacts. And if this is correct, it suggests the age-frequency distributions of impacts on the moon might provide valuable information about the impacts on the Earth or in a solar system. So what it's saying is that, when you get something that bashes into the Earth big enough to cause trouble, around about the same time, you get stuff hitting the moon as well. And that is really quite suggestive of, multiple asteroids being on these collision trajectories rather than just a single big asteroid. And, it raises the issue again, because we talked about this probably a couple of months ago, that Chicxulub was not on its own, that there's evidence for another crater off the coast of East Africa, I beg your pardon, West Africa, that looks as though it's the same age as the Chicxulub crater and is suggestive of Chicxulub, the Chicxulub asteroid being accompanied by other bits and pieces as well, some of which hit the moon. So this is a really interesting piece of information that, we don't just get these things coming in ones. They might come in multiples, and maybe that's because they've already been broken up, perhaps by the gravitational effect of a passage by the sun or something of that sort.
Yeah, I suppose we shouldn't be surprised that events like this would happen in clusters.
Yeah.
We just assume that these asteroids are just out there doing their own thing by themselves. They're not very social. They're usually awkward in the schoolyard and sit by themselves in the corner. But it sounds like it's very possible that the 66 million year ago events surrounding the demise of the dinosaurs might have been a cluster event. It could have been, multiple hits on Earth and the moon.
Yeah, that's right.
Wow.
So they're not small impacts, these that they're talking about. Again, with the results, they've determined that the glass samples suggest that the impacts themselves would have produced craters between 100 and 1,300 meters in diameter. So that's quite big, 1.3 kilometers, with temperatures of the material that was thrown off between 827 and 1,427 degrees Celsius, and sending those little glass beads away more than 150 kilometers after the impact. It's really interesting study that you can determine all that just from little glass beads. And apparently the technique that they used is something called uranium-lead dating, which involves measuring the ratio of uranium isotopes to lead isotopes.
Now, when you say little glass beads, what size are we talking? Are they like granular size, or are we talking bigger?
They're microscopic. The soil itself is very fine, the lunar soil. So I think you're talking about really small particle sizes. I can't give you a number. But they're mostly spherical as well, which is suggestive also of them having been flung into space at high temperature. So they've melted and formed a sphere. Glass beads, I guess you would be measuring their diameters in probably hundredths of a millimeter or thereabouts.
Okay. I'm fascinated by some of the things they've been discovering on the moon, not only from the Apollo missions, but more recently. And it seems to be and I think we talked a couple of weeks ago, and it seems to be a place that's potentially worth farming in the future. And I'm just trying to think of what it was called, but the Chinese found what they think it was a new mineral of some kind on the moon.
Oh, that's right, Changisite. Yeah, we talked about
that's
it.
And potential energy property.
Yes, that's right, because it's got possibly helium-3 in it. Yeah. Interesting stuff.
That really, and I suppose that sort of increases the enthusiasm to do more investigation into what the moon could offer us.
Yeah.
And as we've discussed before, you can't claim ownership of anything beyond Earth, but you can go and, farm the living hell out of it and take it all home, claim it to be your own.
Yeah.
So that's legal. The moon could become I don't know. It could be strip mined in the future.
Well, it's certainly a thought, isn't it, that it wouldn't be impossible. Wouldn't it be awful if we could see mining on the moon from Earth?
It's certainly something that's been portrayed in science fiction.
I'm sure it has, yeah.
I've seen a couple of movies where I think it was the newer edition of the movie The Time Machine, where they were doing something on the moon and they just pushed too hard and the thing cracked.
The whole moon.
The whole moon.
Yeah. Okay.
And caused an awful mess. But, some of the stuff that's happening in reality isn't far off. We're making a heck of a mess in our own atmosphere and just out of the atmosphere in terms of space junk and trying to find ways of dealing with it. I think the UK is launching a new mission soon to try a new way of reducing space junk. But I know the responsibility is on the launcher to fix the problem, but that doesn't always work. It's got to look at the side of the roads to see how people are.
Yes, that's right.
But, this is always interesting, and there's a real space race 2.0 going on at the moment for the moon and for Mars. And I saw another story recently, Fred, where the Indians had a satellite orbiting Mars, and it was there for about I think it was a 14-month mission or something. It lasted 6 years, only just shut itself down the other day.
Yep.
So, there are some amazing things happening. And with all these competing entities and the fact that they're cooperating, I think we're just on the cusp of a giant leap in terms of exploration in our own solar system at the very least. So it's pretty darn exciting when you think about it.
It is. It's good that we're here to cover it as well.
It is, isn't it? Absolutely is, yes. All right, so there'll be obviously more to talk about going forward, but if you want to read up on those glass spheres as they're described, the livescience.com website is a good place to start. They've got a great article on it. This is Space Nuts. Andrew Dunkley here with Professor Fred Watson.
You're listening to Space Nuts, the podcast about astronomy and space science with Andrew Dunkley and Professor Fred Watson.
Now, Fred, let's see if we can sort out a couple of questions from our audience, and they keep them coming in, so we keep answering them. I don't know if we've actually ever answered one correctly, but we will continue to try. And this one's sort of interesting in that it's something that comes up from time to time that people want to know about. And John from Ohio is the latest to sort of touch on this particular thing.
Hello, Fred and Andrew. This is John from Ohio in the United States. I had a question regarding antimatter. So, my understanding is that physicists are generally puzzled by the lack of antimatter in the universe, that equations would generally suggest that there should be equal amounts of matter and antimatter present at any given time. What I am wondering is, are we transitioning from the entirety of matter being regular matter to the entirety of matter being antimatter? And I'm wondering if this is possible when matter crosses the event horizon of a black hole, and perhaps it is accumulating antimatter, within these black holes. rather than simply collapsing matter to a point of singularity, rather there being just a clump of matter existing within these black holes. So I appreciate the show. The chemistry that you two have is wonderful. I wish there was more of it in the world. I always look forward to your shows, and thank you both for the time and effort that you put into this.
Oh, thank you, John. No, it's our pleasure, and lovely words. I'm glad you appreciate it, and we seem to get a few people here and there saying how much they enjoy the program, and the camaraderie, and the sense of humour, and the dad jokes. I don't know how you enjoy dad jokes, but anyway,
Got to be a dad.
No, we do appreciate it. Thank you. Antimatter. Now, we've had a few questions over the years in regard to antimatter. Does it actually exist, or is it theoretical?
Oh no, it definitely exists.
Okay, yeah.
It is so an antimatter particle, in the subatomic world, is the same as the normal particle, but it's got an opposite electrical charge. So you've got an electron which has a negative electrical charge. A positron is its antimatter equivalent with a positive electrical charge. And what happens is if you bring them together, they annihilate. That's why everybody loves them. They annihilate and produce a lot of energy because what you've got is the entire mass of these two particles going into producing energy. It's gamma rays, actually, that they normally produce. And, of course, E equals mc squared is the equation that links that. M is the mass. Then you multiply it by the speed of light, which is an enormous number, squared, which is an even more enormous number, to get the amount of energy that comes out. And that's why it's a very energy-giving process. And in fact, you do get gamma rays with a particular spectral signature, like the fingerprint of them, so that you can tell when you've got two particles that annihilate, basically by analysing the gamma rays.
It must be some other particle I was thinking of that was only theoretical, but there
are a few like that. There's tachyons, which are faster than the speed of light and almost certainly don't exist, but people use them as a theoretical model, which is quite...
Gravitons?
Yeah, well, gravitons probably do exist, but we've never found them. And there's no theory that suggests how they work. So that all that sort of stuff. But yeah, antimatter particles are real. Basically, John's right in saying that it's a mystery why we've got a universe that's mostly made of matter rather than equal chunks of matter and antimatter, which have to be kept apart so they don't blow themselves up.
Yeah.
That's not understood. His idea is interesting, kind of using black holes as a factory for changing the cosmic balance between matter and antimatter. I'm really not enough of a physicist to know whether that's even possible. I think, you kind of end up with all of one kind inside the black hole and all of the other kind not. I suspect it's... I think it's probably a long shot. I think John's drawing a long bow there, if I can mix metaphors. But it's a really interesting idea, and it is a hot topic in astrophysics. Why, if we did have an equal, if the modelling all suggests that there were equal amounts of antimatter and matter produced in the Big Bang, why do we only really see matter? There is antimatter there, but it's in far smaller quantities.
Well, maybe that's a good thing.
It is, yes. You don't want your antimatter self to turn up and shake hands, because that would be
the end.
Yeah, it'd be the end of both of you. Yeah,
but you'd go out with a bang.
Very much so. Yes, E equals mc squared will be the amount of energy you produce.
Yeah. I find it fascinating. Let's assume for a moment there are multiple universes. Is it possible that, in that case, that there could be an antimatter universe where there's more antimatter than matter?
I think it is. I think, if you're going to take a wild leap of fantasy into multiple universes, because we don't know whether there are such things, but there could be, then yes, there might be a universe that's an antimatter universe, which we would really want to stay away from.
Oh, yeah. You don't want to.
Yeah.
I mean, really. I saw something the other day which suggested that prior to the Big Bang, there were multiverses. I don't know the details. I've started a conversation I can't finish. But
well, it's true that there might well have been multiverses. I mean, one of the common models for multiverses is Roger Penrose's one, which suggests that super duper massive black holes, which could form in a universe, will eventually become unstable and explode as another universe. So you might have several of these going off inside different universes. Good stuff.
Sounds like a bit of a worry. So bottom line is we don't really know why there's an imbalance in matter and antimatter in this universe.
Yeah, and I like John's idea, but I don't know whether it's a feasible physical possibility.
So what would happen if antimatter collided with normal matter close to us?
We get a burst of gamma radiation, and if it was enough of the two different sorts, we'd get fried.
Yeah. Okay. Well, let's hope that doesn't happen either.
Yeah, let's hope that.
I'm pretty sure the DART mission couldn't save us in that case.
No, that's right. No, DART's a lot more gentle compared with what we're talking about here. It only hit the asteroid at 6 kilometers per second. That's nothing compared with matter annihilation.
Well, okay. Well, that prompts I'm just keep thinking of questions. But what are the odds of some sort of antimatter matter collision explosion in general, or is this just an unknown?
Well, it must be pretty low because I think
because we're still here.
Sorry, I missed that. Sorry, what?
Because we're still here.
We are still here. Yes. Sorry, you broke up just at that critical point. We are still here. Well, I am. You probably are too. Even though
because of my antimatter microphone, I think that's
yeah.
Of course,
you'd really need. They should put labels on the boxes, shouldn't they? Really, if you get an antimatter microphone by accident delivered to your door and you plug it into your computer, well, you've had it.
The beauty of an antimatter microphone is I can say something lame, but you hear it as a joke and it's funny.
Yes. That's no. There must be a better joke there.
Probably. So the odds are very low of an antimatter matter collision that could
nearby.
Wipe us out.
That's right, but there might be stuff like that going on in the galactic center.
Right. Okay. Stay away from there.
Yeah. Stay away. Yeah.
All right. Thanks, John. I'm not sure we answered your question, but created some interesting thought. Some horrible jokes.
Yes.
Although you would have heard that as fun. So.
Only if you've got an antimatter microphone or antimatter headphones.
Yes. Now, let's move on to this one. This is a what if, a hypothetical, and I really love this question from Zach.
Hey, Andrew and Fred. Love the podcast. Zach from Washington, D.C. Have kind of a silly thought experiment, but it's been keeping me up at night. So imagine you're in this theoretical space fishing boat and you are orbiting a black hole as close to the event horizon as you possibly can be without crossing it. You have a space fishing rod. You cast your line into the black hole past the event horizon. What might you expect that would happen? Would the fishing rod be ripped out of your hand because the line is tugged? Imagine this line is sufficiently strong for this to happen. Would the line snap? I guess what I'm going after is if someone or something is on the outside of the event horizon, but still holding on to an object where the other half of it has passed the event horizon and gone into the black hole, what might we expect to see or experience? Thanks so much. Take care.
Gee, Zach, no wonder you're not sleeping. That's it's complicated. So you're on the interstellar starship Titanic, and you're just outside the event horizon of a black hole, but you decide to go fishing and you hurl your line into the void. What happened?
It's probably the neatest way of getting spaghetti, actually, because that's what the fish would be.
Yeah.
As would your line, as would you. So the event horizon is it's not a sort of barrier, that keeps the black hole intact inside. It's just that height above the black hole from which light can't escape or penetrate. So it is the point of no return. That's the critical thing about the event horizon, but it doesn't really mark. It's not a kind of step in the gravity distribution, if I can put it that way. The gravitational field that you're in is really, really, really strong, no matter which side of the black hole of the event horizon you are. And so you're kind of already spaghettified before you get anywhere near the event horizon. So your line would have to be infinitely strong in order to withstand spaghettification. But I think even infinitely strong fishing lines can't withstand a black hole. So yes, it's a sad ending, really. Your spaceship Titanic. After you've rearranged the deck chairs, it probably gets stretched into something that you wouldn't really want to sit on. So it's.
I don't think you'd have to rearrange the deck chair. That would be done for you.
That's right. That's right. Not only do you rearrange them, you metamorphose them into long, thin things because they're being pulled by the gravity.
It's just hard to imagine that kind of power and that stretching and spaghettifying effect. It's hard to get your head around.
Yeah,
Although I doubt we'll ever witness it, because if we witness it, we're there, and that's the end of that.
That's right. I would imagine it wouldn't not be a pretty sight all round, spaghettification, but yes.
Yeah, so in the future, when we're able to achieve interstellar travel, they will be putting no fishing signs just outside all black holes, Zach.
That sounds right.
Because all you're going to catch is your death of cold.
Oh. You'll be stretched to the limit as well.
Dear, oh dear. Jokes are tearing.
As is our imagination, I have to say.
Yes, indeed. All right. Zach, a quick answer to that one. Don't do it.
Yeah,
just don't do it.
That's the bottom line.
Especially on the ISS Titanic. That would not be good. All right. Lovely to hear from you, and hope all is well in Washington, D.C. That was a quick show, Fred. We got through that one mighty fast.
Did we not? Yeah. Well, it's been good stuff. It's all good.
Indeed.
I think there's merit in brevity at times.
I agree with you, yes. All right. Don't forget, though, if you do have questions for us, we'd certainly love for you to send them in. You can do that through our website, spacenutspodcast.com or spacenuts.io. That's much easier to remember. And click on the AMA link where you can upload your text and audio questions, as long as you've got a device with a microphone. Could be a smartphone, could be a tablet, could be a computer, could be anything like that. Most of them come with microphones built in these days. Just click on the record button and Bob's your uncle. And just tell us your name, could be Bob, and where you're from, and fire away with your question. Love hypotheticals. So if you've got something weird that's keeping you awake at night, like Zach, by all means, send it through to us and we will solve it for you.
Or not.
And if you go to our website, there's also a Send Us Your Audio Question tab on the right-hand side, so you can click on that and send us recorded questions as well. And while you're at the website, check out the latest edition of Astronomy Daily, because my little brother Steve is looking after the show at the moment because I'm not here.
Oh, you're not? No.
I'm not here. I'll tell you all about it when I get back.
Yeah.
It's because we've been hovering around a black hole. There's been a time.
Just watch out for the antimatter as well.
I'll explain it all later. But that brings us to the end of the show. Fred, thank you so much.
Always a pleasure, Andrew, and I look forward to the next one.
Indeed. We'll catch you soon.
Catch you soon.
Professor Fred Watson, astronomer at large. And from me, Andrew Dunkley, thanks for listening to this edition of Space Nuts. We'll catch you on the very next episode. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.
Okay. Press stop. Hang on. Where'd my cursor go? There it is. This new computer, this newfangled thing. All right, stop.